Hello everyone, my name is Devesh Bagura, and in this lecture we are solving the internal test first of the data science. So the first question is, how unstructured data are analyzed? Given the example of the data mining activities to analyze unstructured data. Unstructured data refers to the information that does not have a predefined or easily recognizable structure, format, or organization. Unlike unstructured data, which is stored in a table with a row and column, example, spreadsheet, and databases. Unstructured data is often text heavy, diverse, and stored in its raw format. It makes up a large proportion of the data generated today. Steps for analyzing unstructured text data. The first step is data collection. Gather unstructured data from sources such as social media, customer reviews, emails, or research articles. Now, second step is pre-processing. In the pre-processing, there are the three steps. First is text cleaning, second is tokenization, and third is the stemming and the lemmatization. Now, the first is text cleaning. Remove irrelevant information like punctuation, stop words, and special characters. Second is tokenization. Split the text into smaller unit, words or sentences. Third is stemming and lemmatization. Reduce words to their root forms. Now, the third point is features extraction. Convert text into a structure format. In this feature extraction steps, there are the three steps. First is bags of word, that means BOW, represent text as a word frequency vector. Second is TF-IDF, that means term frequency inverse document frequency, measure word importance in a document relative to a collection of a document. Now next is word embedding. Use techniques like word 2vec, globe, or BERT to represent words as dense vector in a high dimensional space. Now, fourth is analysis technique. Semantic analysis. Identify emotion or sentiment in the text, positive, negative, or neutral. Topic modeling. Discover themes or a topic of a text using method like latent, matrix, allocation, LDA. Now, next is text classification. Categorize text into predefined category. Example, spam detection, product categorization. Now, next is named entity recognition, NER. Identify entities like name, dates, location, and organization in text. Next point is visualization. Use tools like word cloud, heat maps, or network graphs to represent the insight derived from the data. Examples of the data mining activities for the semantic and sentiment analysis. There are the few steps. The first is the collect the data. Second is the pre-process data. Third is the features extraction. Fourth is the apply sentiment analysis, and the fifth is the visualize result. Now, the next question is how text mining techniques you can automate the process of classifying written complaints. Text mining techniques can be used to automate the classifications of the written complaints by the leveraging natural language processing, that means NLP, and machine learning, that means ML. Here are the steps by steps outline how of this can be achieved. The first is the data collection. Gather a data set of a written complaints, typically from the source like first is customer support logs, feedback forms, and complaints email or the social media comments. In short, data includes labels for the complaint categorical, example, billing issues, technical support, product defect, etc. Second point is data pre-processing. Before feeding the text into a model, pre-process it to remove noise and extract meaningful features. Text cleaning. Remove special characters, numbers and punctuation. Second point is convert text to the lowercase for the uniformity. Stop word removal. Eliminate common words that means and the that don't contribute meaning. Tokenization. Break the text into smaller units such as word or phrases. Stemming lemmatization. Reduce word to their base on route from running to run. The next third point is feature extraction. Convert the clean text into a format suitable for the machine learning. The first point is bag of word is BOW. Represent complaints as a vector based on the word frequency. The second is TF-IDF, that means term frequency inverse document frequency. Weight terms by their importance across the dataset. Now the third is word embedding. Use models like Word, 2Vec, Globe or BERT to generate the dense vector representation of the text capturing contextual meaning. Now the fourth is the model training. Select and train the classification models. The first is supervised learning, second is steps. Now the fifth point is model development. Develop the trained model to classify a new complaint automatically. The first is real-time classification and second is batch processing. The next point is feedback and iteration. In the feedback and iteration, there are 2 points: monitor performance and retrain with the updated data. Let's see the example for automating complaint classification. Use case: a bank wants to classify customer complaints into account issues, loan problem, and the credit card dispute. Second point is pipeline. Pre-process the complaint, remove noise, tokenize, lemmatized. Represent the complaints using TF-IDF. Third is train a support vector machine SVM classifiers. Develop the models into the customer support system to tag incoming complaints automatically. Now, the third question is consider the following complaint suggest the approach algorithm to identify the applicable IPC BNS section to the recommended applicable BNS code national category section of IPS Indian Penal Code section. These are the complaint. These are the complaint: theft of my mobile phone by the unknown person at MG Road on 2023 at 2. The phone was stolen when I was shopping at the store. The thief was wearing a blank jacket and had scare on his face. Now see this example. The first point is understand the case detail. First is key information extract from the complaint: event type, theft, object stolen, location, date, time, description of predictor, likely applicable IPC sections. IPC section 378 theft, basic provision for theft. IPC section 379 punishment for the theft up to 3 year imprisonment or fine or both, like BNS section. Now second is automated approach to classify complaint. To classify complaint and recommended the applicable section automatically, use the following workflow. The first is pre-processing. In the pre-processing, text cleaning is the first point. Remove irrelevant details like stop words, unless necessary for the context. Normalized text convert to the lowercase standardized data format. Second is entity recognition. Extract entities, object, mobile phone, predator, location, and date. Now the third is keyword extraction. Extract legal and event related keywords, theft, stolen, shopping. Now the second point is B features. Features extraction. In the feature extraction, there are 2 points: vectorization and the contextual understanding. And the next is algorithm selection. In the algorithm selections, there are the 3 points. First is rule-based classification. Second is supervised learning and pre-trained NLP models. The next point is multi-level classifications, and the third point is implementation pipeline. In this implementation pipeline, first we take the input, and second pre-processing, and third the feature extraction, fourth the classification, and fifth last is the output. Now, the fourth question of the internal paper is explain the suitable metrics to assess the performance of the algorithm in the text mining. When assessing the performance of the algorithms used in the text mining, such as text classification, sentiment analysis, or topic modeling, it's essential to use appropriate metrics that can provide insight into how well the algorithm is performing. The choice of metrics depends on the specific task, just like classification, clustering, regression, and the goal of the analysis. Here are some suitable metrics for evaluating text mining algorithm. The first is accuracy, and the second is precision, third is the recall. Now, try to understand first accuracy. Accuracy is the proportion of the correct prediction, both true positive and true negative, out of the total prediction made. Formula for the accuracy is true positive plus true negative total sample upon text accuracy is equal to frac upon text into true positive plus true negative. Second is the precision. Precision, also called as the positive predictive value, measure the proportion of the true positive predictions out of all the instances that the model classified as positive. Formula for the precision is true positive TP plus false positive is equal to true positive plus false positive upon precision is equal to true positive plus false positive into true positive. Now the third point is recall, is also called as sensitivity. Recalls, also called as sensitivity or true positive rate, measure the proportion of the true positive prediction out of all the actual positive instance in the dataset. Example: in the complaint classification, high recall means that the most complaints are correctly categorized, even if there are some false positive.